Hello, in this video we are going to talk about our logarithm properties, and we're actually starting to get into some of the good stuff now when it comes to logarithms. We've just been tiptoeing around logarithms up until now, and now we're going to finally get into some of the good stuff. So I hope you enjoy it as much as I do. Let me adjust. There we go. So there's several logarithm properties that we have to follow, and the first one is the product property. All right, and that means when you are dealing with a product inside the logarithm, so you can see a times b there, okay, inside of both of those, then we actually split that product up with addition. Okay, so it feels a little odd when you do this, okay, but these are the properties that support the math behind the logarithms, okay? So let's do a couple of examples down here. Okay, so on the left side, okay, you can see that we have three terms, okay, 1, 2, 3. And we're trying to get this into a single logarithm, which means one term. So since these are all base 4, okay, we can combine these together, so it'll be a logarithm base 4. And since we have addition in between, we can combine that as a product. So it'll be logarithm base 4 of x times y times z. Okay. So this is what we call condensing a logarithm, when you have multiple terms and you condense those down to just one term. All right, now expanding, okay, expanding is when we are going to take the logarithm and make it into many terms. Okay, so right now we have one term and we want to expand this out to as many terms as possible and do any simplifying if that's applicable. So you have to separate with addition because this is a product, and we're going to use log base 3 for each of our terms, and we'll put the 5, and then we'll have log base 3 of x, and then we'll have log base 3 of y. Okay, so you just continue the log base 3 through each term, but you can separate the 5, the x, and the y. Okay, and if you look at the next one down here, this will be a log base 2 of 4 plus log base 2 of a. And then we can simplify this. Remember, think about a logarithm. Think about undoing that. So that's 2 to the what gives me a 4. Okay, so 2 squared gives you a 4. So this evaluates to 2. Right, that exponent, right? That exponent is the outcome of that logarithm. Or you can put it in your calculator if you want to. Okay, and so we will have 2 plus logarithm base 2 of a. So I have a quick little funny story here. In a couple of semesters ago, I had a student, it's a girl, and she was never late to class, okay, like, so always kind of early. All right, she was always the first one in the classroom and had all her stuff, very organized. And we actually used to do logarithms at the end of the semester. So we were at the very kind of last few weeks of the semester, and she showed up late one day. She had gotten caught up in this awful traffic jam or whatever, but she still came to class. She was just late. And we had just started our logarithms, and she walked in and she sat down and she just said, "Oh my gosh, I think I have landed on the planet Mars," because she just looked up and saw all this logarithm stuff on the board, and it looks very weird. Okay, if you're thinking that, like, wow, these are weird, they do look weird. Now once you get used to them, you get very accustomed to seeing them. But if you haven't done much with logarithms, it is very odd and awkward at the beginning. Okay, so if you're feeling that, I just want to let you know everybody else feels that way too. So that's just normal. Just keep working with them and you'll figure it out. So the next property is the logarithm of a power. Okay, so when you have a power, okay, you can see there's a power there, then we actually bring it down to the front of the logarithm. Okay, and you have to be a little bit careful sometimes with some of the steps there. But I'll show you some of the little tricks as we go through these examples. So if you see your example here, they're saying rewrite the logarithm so it does not contain a power. So it has a power now, okay, but we can bring that down to the front of the logarithm. Okay, so this is 3 times the logarithm base 2 of 5, and then we're done. We have changed that to a logarithm that no longer contains a power. All right, so one of the things you got to watch out for is when they give you a square root or maybe a cube root, and you need to remember that you can write square roots and cube roots as rational exponents. So if you have the square root of 5, that is the same thing as 5 to the 1/2. Okay, if that was a cube root, all right, cube root of 5, that's the same as 5 to the 1/3. All right, fourth root would be 5 to the 1/4, and that's just a quick little review there. Okay, so the first thing you do want to do, what you want to do, tongue-tied there, is rewrite that with the 1/2 exponent, and then that's a power that you can bring down to the front. We'll actually use that quite a bit when we get into our equations and more complicated problems down the road. Okay, so let's talk about the quotient property. So logarithm of quotient, okay, and that's when you're dividing, all right, and you can see the division is set up here, and we can take that division and we can break it apart with subtraction. Okay, now it's very important that you pay attention to the order. So the A was on top. Make sure that A is first, okay, and be careful that you don't switch the order, because with subtraction, since subtraction is not commutative, which that means you can't just switch the order of subtraction and get the same answer, you have to be very careful how you write your subtraction when you're setting up the terms. So let's do a couple of quick examples here. So we have subtraction, so I can use my quotient property, okay? So this will be logarithm base 3, and I want to put the x in the top and the y in the bottom, all right? And the next problem here will be a logarithm base 4. And you have to be careful because we've got subtraction and then subtraction again. The A definitely needs to go on the top, but then you want to make sure the B and the C get into the bottom because of those two subtraction signs. And thinking about the quotient property. One mistake students do, this is very common, is they want to write the quotient property like this. They want to repeat the logarithm on the top and the bottom. Don't do that, okay? Make sure you just have the one logarithm as I've shown you here, and then you write the fraction, okay? I'm actually going to go back up and show you a common mistake that students make on these problems as well. Just sometimes I think when you see, you know, mistakes or inaccurate ways to do things, that helps you to remember not to do that. But one thing that students will do on a problem like this, they'll say something like this: logarithm base 3 of 5 plus x plus y, like that, okay? So they don't repeat that logarithm base 3 into each term, so don't do that, okay? Watch out for that. All right, so let's keep going here. So now we have the quotient property, and we're going to go the other way. We're going to rewrite the logarithm so it's not a quotient. So we're going to use the subtraction. So it'll be natural log of x minus natural log of y. Just make sure you have the x first and then the y. And then here we'll have log base 2 of a minus log base 2 of b. Okay. So right now we're just working on the basic, very basic properties. Okay. Here's another, be careful. Okay, a lot of students want to do this. They'll say natural log of x minus y. Don't do that. Okay. So now it gets fun. Okay, we're going to start putting it all together, and this is where they combine all of the properties together, and then you have to expand the logarithm out as far as you can using all of the properties combined together. So you can obviously see we have a fraction, right? We have a fraction here, so the quotient property is definitely going to be involved. So we're going to take that and we're going to separate it with subtraction. So I'm kind of going to come up here a little bit. So it'll be logarithm base 3 of x squared minus logarithm base 3 of yz to the third. Okay. And whenever I have more than one thing inside the logarithm, I use parentheses, and I'd suggest you do that as well. That makes it easier to keep up with things. All right, now technically right here, this is a product. Okay, if we just ignore this first part here for just a second, we would actually break this apart using a product. Okay, so let me show you that part real quick. So that'll be a logarithm base 3 of y plus logarithm base 3 of z cubed. All right, and that's just using our product rule. But then we have this subtraction in front, so you actually want to think about brackets being there, and that subtraction will distribute through. Okay, so I can also go ahead and bring this 2 down to the front using the power rule. So it'll be a logarithm, 2 times logarithm base 3 of x minus this whole group. And then, like I said, we can distribute this subtraction through, and we can also bring this 3 down to the front when we get to that step. So it'll be 2 logarithm base 3 of x minus logarithm base 3 of y minus 3 times the logarithm base 3 of z. Okay, so be careful. This is a very common spot where students forget, okay, that subtraction. So watch out for that. And if you think back to the original problem, you know, both the y and the z were in the bottom of the fraction. So that should kind of trigger your thoughts to both of those terms should have the subtraction there just because they were in the bottom of the fraction. All right. Okay, let's do this next one here. So you want to think about your quotient property. So it'll be a log base 2 of a cubed b to the 4th minus log base 2 of the square root of c. And they wrote the 2 there. This is actually an example that I pulled off of a PowerPoint from something else we used a long time ago. And I don't know why they wrote the 2 there. I keep meaning to take that off, and then I always forget. And so anyways, we don't need to write that 2. It's understood to be a 2. And so then this is your product property up here. So this is log base 2 of a cubed plus log base 2 of b to the 4th. Okay, and then I'm also going to change the c to the 1/2. Okay, and then I brought the subtraction down, and then I just need to use my power rule to bring those exponents down. So it'll be 3 times logarithm base 2 of a plus 4 times logarithm base 2 of b minus 1/2 logarithm base 2 of c. And then you have expanded that logarithm as far as you can go. Okay, so the idea here when you expand, you want to make sure that you no longer have a product, a quotient, or a power in there, okay, and that you've pulled it out to as many terms as possible. All right, so let's go to this last little group of problems here, and we're going to condense this down. Okay, so one thing you want to think about is this 5 can come up, this 1/3 can come up, because we're kind of going the other direction now, right? So we'll have logarithm base 2 of x to the 5th minus logarithm base 2 of y plus logarithm base 2 of z to the 1/3. Okay. All right, now be very, very careful here because we have subtraction, okay, but we have addition. Change to a different color here. We have addition here, all right? So just be mindful of, what that subtraction means, okay? That subtraction is telling you the quotient property is involved there. The addition sign is telling you the product property is involved. So when we bring this together, all right, it's going to be logarithm base 2 of x to the 5th, okay, and I can multiply the z to the 1/3, but I need to divide by the y, okay, because the y had that subtraction, okay, it had the subtraction, so it's got to go in the bottom, all right. And then the only other thing you can do here is change the z to the cube root, okay, so instead of saying to the 1/3, you can write that as the cube root of z. All right, let's do one more here. Okay, so here's where I encourage you to pause the video, try this problem on your own, see if you can get it, and then play the video to see how you did and if you got it all correct. Okay, so bring your exponents up. All right, so it'll be natural log of a squared minus natural log of b minus natural log of c to the 1/2 plus natural log of d cubed. Okay, and then notice we've got subtraction here and here. Actually, you know what, I'm gonna actually undo that because I want to stick to the same colors I was using before. So I used the purple there. Okay, so purple, purple. All right, and so that's your quotient rule, and then we have addition there. Okay, so be very careful how you set this all up in your next step. So you'll have natural log, and then we'll have a squared, and then I can multiply the d cubed on the top, but then I need to divide by the b and the c to 1/2. Okay, and then the last thing you can do is just rewrite that as the square root of c. So it'll be natural log of a squared d cubed b is the square root of c. Okay, and you have condensed that down as far as you can go. So it's actually kind of fun once you get the hang of these. They do take some practice though, so that's where the lab manual and the WebAssign and that kind of stuff comes into play. The more of these you do, the easier they get, and then later down the road we come back to this when we're solving our logarithm equations, and you need all of these skills to survive those equations. So make sure you're asking questions if you have them.